So this is unit 2, we're in A2Pure, and it's a bit more in trigonometry, so just a wee bit with trig identities. I'm just showing some of the new identities we're dealing with, and then solving more trig equations using those. So we already hopefully know tan x is sine x over cos x. We also know sine squared plus cos squared equals 1. But if you divide both sides by cos squared, here we get sine squared over cos squared, that would give us tan squared. Here, if cos squared over cos squared, that would give us 1, and then 1 over cos squared is sec squared. So this is a new identity then that we would sometimes use in to help solve some of the bits and pieces. Instead of dividing by cos squared, we divide by sine squared. We get sine squared over sine squared, which gives us 1. Cos squared over sine squared, that's like an upside down tan, so that's going to give us cot squared, and then 1 over sine squared, which is cosec squared. So in order to solve kind of trig equations like this, or like this, we need to use some of these identities above in terms of being able to do it. So let's take a wee look at example 1 and see how we get on. So in this one we have a tan squared and we have a sec, and 9 times out of 10 the way we want to solve our trig equations is to set it up in such a way so we have the same trig identity each time. So we do have something with tan squared and sec in it. So we know that tan squared equals sec squared x take away 1. So if I change my tan squared theta here for a sec squared theta take away 1, now take things nice and slowly here, don't be doing too much working out. So sec squared theta take away 1 plus 5 is 7 sec theta. I would rearrange this, 3 sec squared theta, then that's going to be minus 3 plus 5, so that's going to give me a 2, and then I'm going to take this over here, so minus 7 sec theta plus 2 equals 0. So what have we done? We've got rid of our tan squared, which is into sec squared. We now have a quadratic with sec, so we can now solve that. So that factorizes. You might want to change this to an x, that'll be fine, or a t, and factorize it out, then change it back in. But I think that gives us 3 sec theta take away 1, and then gives us sec theta take away 2, both equal 0. So what do we have then from here? We have sec theta equals a third, and we have sec theta equals 2. That means we have cos theta is 3, or we have cos theta is a half. Cos theta equals 3 is going to have no solutions. We can't have cos being more than 1, so there's no solution for that. So we just need to solve that cos theta equals a half. And if I look back up on the top, it's between 0 and 360 degrees. So let's do our cast diagram for that. We would find our basic angle. Most people know there that theta in this case is going to give me 60. So we would have this one here, and it's 60. And our other place where cos is positive is down here. If we have C, A, S, T, so we're going to have 60 degrees going around that way, and then all the way around to there, because it's between 0 and 360, so it's going to be 300 degrees. So our two values in and our two answers. Theta is 60, or theta is 300. And as I say, they're both in degrees.